If you remember when we talked about similarity and you had to find a similarity ratio, that was based on length, right? We took a length on one shape and set up a ratio with the corresponding side on the other shape. We simplified the fraction and said, here's our similarity ratio. If you have two figures that you are told are similar, and we know the lengths of a pair of corresponding sides, then we can set up the similarity ratio. And remember, the important part about the similarity ratio is it's not two lengths on the same side. It's one side or one shape to the other. So it's not two lengths on the same shape. You go one shape to the other. So the similarity ratio of the smaller to the larger figure would be 6 to 9, which would simplify to 2/3. Okay, so your similarity ratio would be 2/3. Now, if I were to throw in the other sides, okay, they're all going to be in that ratio, right? 2 to 3. So if I were to add up the length of the sides and get the perimeter, it's still length. The perimeter should be in the same ratio, 2 to 3. Okay, it'd be like saying, okay, well, if this shape is twice as big as that one, then the perimeter should be twice as big as the first perimeter, right? Does that make sense? So if you're dealing with lengths, then your perimeter ratio is actually the same as your similarity ratio, okay? So we have a similarity ratio of A over B, which means the perimeter ratio would also be A over B. I wouldn't have to add up the sides of the figure to get the perimeter to find the ratio of the perimeters. I would just have to take a corresponding pair of sides, which is kind of nice. Okay, so you don't actually find the perimeter to get the perimeter ratio. It's in the same ratio as similarity. Okay. Now, one thing we want to be careful of and leave some space, because we're also going to talk about the area ratio. But easier, I think, for you guys to understand if we use a shape where you can see what the area is. So if we use two squares, and I give you a side length of 5, and we'll do 10, make it easy. So this square is twice as big, right? Okay. Well, the area of this square would be 5 times 5, right? Which is 25, and the area of this square would be 10 times 10, which is 100, okay? You can see that the area is not twice as big, right? 100 is not twice as big as 25, but there is a relationship. So using 5 and 10 as our similarity ratio, okay, you'd have 5 over 10, or 1 to 2, for your similarity ratio, which means your perimeter ratio would also be 1 to 2. Okay. Our area ratio would be 25 to 100, right? Okay. But 25 to 100 simplifies to what? 1/4. So when you compare the perimeter, the similarity of the perimeter and the area, okay, think of it in these terms. Area is squared, right? It's in square units. So we can find it by squaring the similarity or perimeter ratio. Okay, so if I want the area ratio and I know A and B, then the area ratio should be A squared over B squared. Okay, and you can see it. 25 to 100 is 1/4, and 1/4 is 1/2 squared. Okay, top and bottom squared. So if I went back up here and I wanted the area ratio, I wouldn't have to find the area of these figures to know that the area ratio should be 4/9, right? Okay, now if we know the area ratio, then we can also go on to say, well, then if the area of this is 100, I can set up a proportion and find the area of that, knowing that the ratio should be 4:9. Okay, so we're going to get to some of those, but for starters, you need to know that if you know similarity, then you also know perimeter, and all you have to do to find the area ratio is square it. Now going back the other direction, if I gave you the area ratios, then you could square root them to find similarity and perimeter. Okay, so we can go back and forth between those. So we're actually going to be using these to find areas. And again, you're not going to be finding the areas using the area formulas. We won't have enough information to plug into a formula, and you're not supposed to do that. We're just using the information that we have. Okay, so the first problem tells us the area of a smaller regular pentagon is about 27.5. Okay, what is the best approximation for the area of the larger? And they've got a picture here of the two pentagons. With the side length for each. Okay, so they give us the area of the smaller. And they want us to find the area of the larger. Now, this general idea should carry you on into doing the same thing later with volume. We'll have to tweak it a little bit, okay? But the general idea is find the ratio of the measurement you wish to find, or you wish to calculate. I want to find twice. So if I want to calculate the area, then I need to know the area ratio, okay? So, for example, if you're finding area, you need the area ratio. Later on, if I'm looking to find a volume, I would need the volume ratio. If I want to go back and find perimeter, I'm going to need a perimeter or similarity ratio, okay? So it's whatever your end result is, you're going to need that ratio first. And we're going to talk about how to get there, okay? So we don't have the area ratio, but we do have side lengths, okay? So the similarity ratio is going to be 4 to 10. Now, when you're using it to turn around and find the area, it's up to you. You won't have to simplify it unless it's not in the form that's useful, okay? If you're trying to take the square root of something that is not a perfect square, and you simplify it and then it will be a perfect square, then by all means you want to simplify it. But in this case, I am squaring to get the area ratio, so simplify it or don't, it's still going to work in your proportion, okay? Once you set up a proportion, they don't have to be simplified. So 4/10, which means my area ratio would be what? 16 over 100, because I'm going to do 4 over 10 squared, right? And when you square a fraction, you square the top and the bottom. Once you get the right ratio, you are going to set up a proportion. So if my area ratio is 16 to 100, clearly the smaller area should be on top, right? Then I'm going to finish my proportion and I'm going to take the smaller area, 27.5, and set it on the top with your variable on the bottom. And from here, how do I solve for A? Yes. Okay, so we set up the proportion, cross multiply to solve. So you have 16A equals 2750. Divide out 16, and A would be a 171.875, and you're going to round to the nearest, it's an approximation, so round to the whole number, so about 172. And that's still an area, so it is square centimeters. Yes. That's what they gave us. Yeah. It could be something else, yeah. Generally what's going to happen is they're going to give you a side length on each and an area of one or the other, and then have you find that area. So you're going to set up the area ratio, do your proportion. Yeah, so the side lengths are what we use to find the area ratio. But they would have to give you, I suppose, so they're going to give you the area of the first or the second figure. Not that we couldn't calculate this, you just learned how to do those. But the point is on these that you shouldn't have to calculate them if you know the area of one. You don't have to calculate the other. Okay, they might not give you a picture. So if they said corresponding sides of two similar parallelograms are in the ratio 3 to 4, okay, then we know we have a similarity ratio of 3 to 4. The area of the larger equals 96 square inches. Find the area of the smaller. Okay, they're giving you similarity. So your similarity ratio is 3/4, which means your area ratio would be what? 9/16. And then we can set up a proportion. So 9 over 16 would equal
A over 96.
Yeah, you're finding the smaller. You just want to make sure you get these in the right place. So you're going to put A where the smaller one is on top and 96 on the bottom. So you'd have 16A equals 9 times 96. So 864 divided by 16. So A would be 54 square inches. Okay, one last problem. If they give you two areas, you should be able to go back and find the similarity ratio. Okay. So if the area of two figures are, or if the areas are 50 centimeters squared and 98 centimeters squared, what is the similarity ratio? Now, they could ask you for similarity or perimeter. It doesn't matter. They're the same thing. Okay? So sometimes people see what's the perimeter ratio, and they're like, how do I find the perimeter when I only have the area? You don't have to find the perimeter. Okay? You have the ratio of the areas. So again, you go to the desired ratio for what you're looking for. Now in this case, we're not finding perimeter or anything like that. So you've got the two areas. So our area ratio is 50 over 98. The first thing you should be looking at, and remember this is A squared over B squared, right? For a perimeter or similarity ratio, we simply want A over B, but you're not going to want decimals as answers if you can avoid it. So this is what I was talking about. In some cases, you're going to want to simplify that before you square root. Obviously, you don't want to square root 50 and 98, but if I reduce this, 50 over 98 would be 25 over 49, which looks much nicer to square root, right?
7
Yep, so to get A over B, we're going to square root 25 over 49. Yes?
Did you do 5 over 7?
Yes. That's how we're getting 5 over 7, taking the square roots. So 5 over 7 would be our similarity and perimeter ratio. So the similarity ratio is 5 over 7, and if we needed it, the perimeter ratio is also 5 over 7. Okay, so I think everything here should be pretty straightforward. I forgot to write your assignment up there. So you're going to be on page 556, 1 to 8, 9 to 21 odd, 22, and I'm going to cancel 27, so don't worry about 27. Okay.